Q8101. To reduce the power output of an engine equipped with a constant speed propeller and operating near maximum BMEP. A. Manifold pressure is reduced with the throttle control before the RPM is reduced with the propeller control. B. Manifold pressure is reduced with the propeller control before the RPM is reduced with the throttle control. C. RPM is reduced with the propeller control before the manifold pressure is reduced with the throttle control. The correct answer is A. It's crucial to lessen the manifold pressure by delaying the throttle while changing the power setting of an engine with a constant speed propeller. Before the propeller pitch control lowers the RPM. When performed incorrectly, the combination of low RPM and high manifold pressure can result in cylinder pressures that are high enough to badly harm an engine. Q8102. One of the best indicators of reciprocating engine combustion chamber problems is A. Excessive engine vibration. B. Starting difficulties. C. Spark plug condition. The correct answer is C. Spark plug condition is one of the best indicators of combustion chamber problems in reciprocating engines. The spark plug plays a critical role in igniting the air-fuel mixture inside the engine's combustion chamber. By examining the appearance and condition of the spark plug, it is possible to identify various combustion-related issues. When combustion chamber problems occur, such as improper fuel-air mixture, ignition problems, or engine overheating, they can leave specific telltale signs on the spark plugs. Q8103. What could cause excessive pressure buildup in the crankcase of a reciprocating engine? A. Plugged crankcase breather. B. Improper warm-up operation. C. An excessive quantity of oil. The correct answer is A. Excessive pressure buildup in the crankcase of a reciprocating engine can be caused by a variety of factors, but one common cause is a plugged crankcase breather. The crankcase breather is a component designed to release excess pressure and gases that accumulate inside the engine's crankcase. When the crankcase breather becomes clogged or blocked, it restricts the airflow and hampers the proper ventilation of the crankcase. As a result, pressure starts to build up inside the crankcase. This pressure buildup can lead to several issues, including oil leaks. Excessive pressure can force oil to leak out of seals and gaskets, leading to oil leaks in various parts of the engine. Seal damage. The increased pressure can cause seals, such as crankshaft seals or gasket seals, to fail prematurely, resulting in further oil leaks and potential loss of engine lubrication. Reduced engine performance. Excessive pressure in the crankcase can create resistance to the rotation of the crankshaft, which can lead to increased drag on the engine and a decrease in overall performance. Q8104. Excessive valve clearance in a piston engine. A. Increases valve overlap. B. Increases valve opening time. C. Decreases valve overlap. The correct answer is C. Excessive valve clearance in a piston engine refers to the condition where the clearance between the valve and its corresponding valve seat or tappet is larger than the manufacturer's specified tolerance. This excess clearance can have an impact on the valve timing and operation. Valve overlap refers to the period during the engine's cycle when both the intake and exhaust valves are partially open at the same time. It is an essential parameter for optimizing engine performance, especially at high engine speeds. When there is excessive valve clearance, it means that the valve does not fully close during the compression and combustion strokes as intended. This results in a reduction of the valve overlap period since the exhaust valve starts to close earlier and the intake valve starts to open later than the design timing. Q8105. To what altitude will a turbocharged engine maintain sea level pressure? A. Critical altitude. B. Service ceiling. C. Pressure altitude. The correct answer is A. A turbocharged engine can maintain sea level pressure up to its critical altitude. The critical altitude is the maximum altitude at which the turbocharged engine is capable of maintaining sea level pressure in the intake manifold. As an aircraft climbs higher in the atmosphere, the air density decreases, resulting in reduced engine performance. However, a turbocharged engine utilizes a compressor, often driven by exhaust gases, to compress the intake air and maintain a higher pressure in the intake manifold. This allows the engine to continue operating as if it were at sea level, even at higher altitudes. The critical altitude is the point at which the turbocharger can no longer provide enough compression to maintain sea level pressure in the intake manifold. Beyond the critical altitude, the engine's power output will start to decrease due to the reduced air density and the inability of the turbocharger to compensate adequately. On the other hand, the service ceiling refers to the maximum altitude at which an aircraft can sustain a specific rate of climb, typically 100 feet per minute. It is not directly related to the maintenance of sea level pressure by a turbocharged engine.